So let's move straight ahead into the next example. We've talked about the product rule for exponents, what to do when you multiply powers of a common base. Now let's take the next step and talk about the opposite. What happens if we want to divide powers of a common base? So what's our strategy going to be in this problem? Well, exactly the same as in the previous problem. We're going to find the powers, and then we're going to move the power arithmetic into exponent arithmetic instead, using the same layer cake of arithmetic operations. So whatever we do to the power, we're going to do one step lower to the exponent instead. First, let's do as we did before and locate the powers. So where are the power expressions in this example? Remembering the order of operations, and if there were coefficients here, we would remember not to include them in the bases of the powers. So we have a total of 4 powers written in this problem. Y to the 4th and x to the 6th are each powers in the numerator. Y to the 7th and x are each powers in the denominator. So we know where the powers are now. And just like before, I want to try to rearrange the powers in this expression in a way that lines up the like factors, the factors that have the same base. In other words, I want to make it really obvious to myself which powers I'm going to be able to combine. Specifically, I can combine the powers of y together because they're powers of the same base. I can combine the powers of x together because their powers are the same base. So I want to just make that obvious by kind of lining up the y's above one another, lining up the x's above one another. If there are any hidden exponents, any hidden ones, I should make sure that I put those in immediately. I'm going to do that because that x that's in the denominator is missing a hidden 1. So I'm going to put it there. So now we have all 4 of our powers. We know which ones are like to which and what the exponent is for each. So now we can move the arithmetic that's happening to the powers into the exponents instead. According to the arithmetic layer cake, if I'm going to divide powers, I can instead choose to subtract their exponents. So let's implement that strategy. I can simplify the powers of y that I have here by subtracting their exponents, 4 from 7. And I can simplify the powers of x by subtracting those exponents, 6 minus 1. So how many y's do I have in total? I have 4 minus 7, or -3, powers of y. How many x's do I have in total? I have 6 minus 1, or 5, powers of x in my final answer. And now we've accomplished all the arithmetic and the exponents that we need to accomplish. We just turned division of the powers into subtraction of the exponents. Finally, all we need to do now is simplify. Let's take any negative exponents that we have and turn them positive by, again, trading multiplication for division. And there's only one negative exponent here. It happens to be attached to the y to the -3 power. So we can fix that by seeing a hidden multiplication by 1 in front of it. That turns out to just be kind of a convenient little factor because otherwise there's no operation in front of the y to the power -3 to do anything with. But now we see that there's secretly a multiplication sign there, 1 times y to the -3. So now we know if we want to turn that negative into a positive, we just need to turn that multiplication in front of it into division instead. Same strategy that we've used every time to turn a negative exponent into a positive one. So we'll turn that multiplication sign into a division sign, 1 divided by y to the 3rd times x to the 5th. And reading the order of operations from left to right, that means that the y to the 3rd power is really part of a denominator, where the x to the 5th is not. And we don't need that factor of 1 in our final answer, so just tidy that up a little bit. Our final answer here is going to be x to the 5th divided by y to the 3rd. So again, the strategy was to use the so-called quotient rule of exponents, and we knew that not only because it was in the title, but also because we were dividing powers whose bases were the same. We were dividing powers of y by one another. We were dividing powers of x by one another. And as a result, we can ship that arithmetic from the power level to the exponent level instead. Instead of dividing in the powers, we'll subtract in the exponents. And subtracting in the exponents gave me a total of -3 powers of y and +5 powers of x. Finishing that up, all we needed to do was to move that -3 powers of y into +3 powers of y in a denominator instead.